All right, everybody. Here's what we're going to talk about first. We're going to talk about ionic compounds, how they form in detail, and then we'll talk about covalent bonds, how they form in detail. All right? So we've talked about the properties of both of them already, that ionic bonds are stronger than covalent, and that's why we saw the results we got in our lab. But let's talk about how they actually form. So, how ionic bonds form. And we've talked about this a little bit already, but we're going to do two of them as a class. I'm going to show you them up here. And then you're going to do a few with whiteboards just to make sure you get it. Because it's not totally in your book. There's something like it in your book, but not totally what I'm showing you here. And I will expect you to be able to do what I'm showing you here. So maybe make a star by this in your notes, because this seems to be one of the parts on the test that people forget to make sure they can do. All right, we're going to start with I always give you a metal and a non-metal. So if I give you potassium and fluorine, and I ask you how that ionic bond forms, just show me how it forms. First of all, we need to talk about valence electrons and how valence electrons are shown around atoms. So I'm going to go ahead and go across the second period and do that with you, and I'll erase it from here. But how they are shown. So here's lithium, beryllium. I'm just going to go across the second period, and then we'll come back to this problem. Boron, carbon, nitrogen, oxygen, fluorine, neon. All right? As we've talked about already, each of these have a certain amount of valence electrons, 1 through 8. There's a possibility of having 8 total, and that's really what the goal is for atoms to have 8 valence electrons that look like a noble gas. It's called the octet rule. Lithium has 1. So there is 1 valence electron. We can show this on any side, but let's just go with neon first, actually, to show you what the goal is. To have 2, 2, yikes, 2, it's not catching up with me. All right, so there it has a total of 8. Okay, that'd be the fulfilling the octet rule. Neon has 2 on each side. That is how electrons can be shown. It's called a Lewis dot diagram, showing dots as electrons. Before we showed arrows as electrons in chapter 4. All right, now we'll go backwards. Fluorine has 7 valence electrons because it's group 17. So I want to leave one side with only 1. It doesn't matter which one you pick. I just picked that side. So don't think, oh, the left side always has to be the lone one. No, it doesn't. Oxygen has 6, so I'm going to pick 2 sides to be only 1 electron. But it would be incorrect to do it this way. This is incorrect. Each side has to have 1 before any side can have 2. Kind of like the old Hund's rule deal. And I hate to go backwards, but I'm going to do that just because it helps show that. So lithium has 1. I can put 1 on any side. It doesn't matter. Beryllium has 2, and it has 2 valence electrons, and it's going to have 1 on 2 different sides. That's how you show these dots. Boron has 3 valence electrons because it's in group 13, so I'm going to put 3 dots on 3 separate sides. It does not matter which sides. I know I picked the top to be empty. It doesn't matter if the right side would be empty. So don't think where the dots go make that big of a difference. It's just how you fill them in kind of does. It really does. Carbon has 4 valence electrons, and they go on 4 separate sides. Then when you get to nitrogen, there's 5, and then you can start filling in one of the sides having a 5th or a 2nd electron. Doesn't matter which side at all. So if I'm anything in lithium or in anything in group 1, I'm going to look like this because I have 1 valence electron. Anything in group 2 would also look like this. Anything below beryllium would have the same dot structure. Anything below boron would have the same dot structure. Carbon, nitrogen, oxygen, fluorine, neon. Everything in the group would have the same dot structure as this because it has the same number of valence electrons. So any element from the periodic table, we should be able to come up with the dot structure. So we erase all that and use that information to do potassium and fluorine. So how many valence electrons does potassium have? 1. How many valence electrons does fluorine have? How many? I heard a couple different things. It's in group 17, so 7. Okay, so what happens here? It is an ionic bond, right? We have a transfer of an electron. Again, this is not in your book, and yes, I will expect you to be able to show me this. There is a transfer of electron from potassium to fluorine. And when that transfer occurs, what is our end result? What is potassium now? It's a 1 plus, right? And the number is supposed to come before the plus, so I'll just stay with that. It's not the end of the world, but it's supposed to. Now fluorine has 8 valence electrons, and what is it? A 1 minus. So the metal has lost its electron to the nonmetal. The metal has formed a cation. The nonmetal has formed an anion. And if we wanted to look at this, this is the most basic you get because there's just one of each. But in reality, if you have potassium chloride or potassium fluoride or sodium chloride, there's just millions and millions and millions of these little ions sitting next to each other. They're just positive, negative, positive, negative, positive, negative, three-dimensionally all around each other. If you have a crystal of this that you can see with your eyes, you're looking at millions and millions and millions and millions of ions. And if you put it in water, they break apart into their separate ions. Questions so far? So that's just kind of the more basic type of 1 electron lost, 1 electron gained. All right? And if I want to get the actual formula, the formula of this compound, it would be KF. And the naming we'll come to later, but this would be potassium fluoride, how we understand it. This would be KF as the actual formula of potassium fluoride. For this right now, I'm just showing you. If I ask you how it forms, I want you to show me the electrons moving and then this. Now, one question before I erase it is, why doesn't potassium have 8 around it? Well, it lost 1, and it kind of does still have 8 around it, but it lost its 1, and now it still looks like a noble gas. It looks like argon, but it lost its 1 valence. And it looks like argon, and it's happy, where this has gained 1 to get 8, and looks now like neon. So the metals will have an empty, no dots, and the nonmetals will have 8 when it's done.
Wait, why does potassium look like argon?
Because potassium typically has 19 electrons. If it loses 1, it now has 18 and looks like argon. So all of these bonds, just a reminder again, all of these bonds occur to become like noble gases. Whether it's ionic or covalent, they are happening so they look like noble gases. All right? We'll do one more and then we'll let you try some at boards. Let's say we have calcium and bromine. How many valence electrons does calcium have? 2. So I'm going to do it like this, plus bromine. How many valence electrons does bromine have? 7. Again, I can make that open spot on any side, and I'll do it here just so it's closer. Calcium is going to transfer an electron to bromine. Which one of those atoms is now stable? The bromine is. So what's my problem here? Calcium needs 1 more bromine to donate to, doesn't it? And this is also showing why we have the ratio that we have in ionic compounds. Sometimes it's a 1-to-1 ratio, and this time it can't be. We're going to have calcium, which has lost 2 electrons. So what charge is calcium making? 2 plus, yep. And we have bromine now next to it, 2 of them, We can draw it like this, that's fine. Showing that there's 2 of them now. With 8 valence electrons, and each bromine has what charge? Each bromine, 1 minus. Overall, the charge has to equal 0. I have a calcium with a 2 plus. I have 2 bromines, each with a 1 minus. If I add all those charges up, I have 0 charge.
So why can't we just call it 2 minus?
Because it is for each ion gets a charge. That's why it cannot be 2 minus. It's how much each atom loses and becomes an ion. So what I want you to do now is get whiteboards